All right, so we know the unit circle, right? We got our sines and our cosines, our 16 angles. We're just gonna review a little bit of what we already know, that we can write sine as opposite over hypotenuse. Cosine, of course, is adjacent over hypotenuse. And tangent is opposite over adjacent. So, ka and toa. We also know that cosecant can be 1 over sine, or we can think of it as hypotenuse over opposite. Secant is 1 over cos, or hypotenuse over adjacent. And cotan is 1 over tan, which is the same thing as adjacent over opposite. So ka toa, cho, sha, keo, right? Here's a big reveal. Another way to express tangent, you ready? Tangent can be expressed as sine over cos. What? Sine over cos? How is tangent sine over cos? Well, if you think about it, sine is equal to opposite over hypotenuse. You don't have to write this down, you can just watch. Opposite over hypotenuse, and cosine, of course, is adjacent over hypotenuse. And we know that when you divide fractions, it's the same as multiplying by the reciprocal. And that turns it into opposite over adjacent, which is what tan is. So tan can be expressed as sine over cos, which means that another way to express cotan is cos over sine. So we've got some little extras. We got our regular old SOHCAHTOA, CHO, SHA, KO, and then also that tan can be expressed as sine over cos, and cotan is cos over sine. So now we're going to go around the unit circle, and we're going to go back to our 16 angles, starting with our 30 degrees. And we're going to be able to find not only the sine and cosine of the 30-degree angle, right? Remember, hypotenuse is always 1. This is 1 half, side opposite the 30, square root of 3 over 2, side opposite the 60, 1 half, right? So we know the ordered pair, and we know the sine and cosine, right? 1/3, square root of 3 over 2, 1 half. We know the cos, we know the sine. But now we want to do the tan. You have two choices. You could do TOA, right, which is opposite over adjacent. Or you could think of it as sine over cos. Either way, it's 1 half over square root of 3 over 2. And you might be like, didn't I already kind of know that the tan of 30 is root 3 over 3? Yes, you did. Right? So you might have even been able to do that by heart. But that's like the reasoning behind it. If I go to the next one is cotan of a 45, okay? So I'm still in the first quadrant, 45 degrees, 45, 45, 90. Each time I'm drawing the triangle, root 2 over 2, root 2 over 2. Cotan, right? Well, if I get my ordered pair here, I know the cos, I know the sine. And we said that cotan is the same as either adjacent over opposite or cos over sine. So it's root 2 over 2 over root 2 over 2, which is 1. Cotan of a 45 is 1. Ta-da! Now we're going to march into different quadrants here. Actually, you know what? I'm going to do number 4, secant of a 90. Because 90 degrees right here, remember the radius of the circle is 1. That ordered pair is 0, 1. The cos of a 90, maybe I'll just write underneath, cos of a 90 is 0, sine of a 90 is 1. Secant is 1 over cos. Cos of a 90 we just said is 0, 1 over 0, undefined. 1 divided by 0, of course, is undefined. So there is no answer really to secant of a 90. Okay, now we're going to go into the second quadrant, 120. So now in the second quadrant and in any other quadrants besides quadrant 1, we just got to be mindful of our positive and negative signs, right? So it's still our 30, 60, 90 triangle. We still have a hypotenuse of 1. But we want to remember that in the second quadrant, when I go left and up, it's a negative x value. So the ordered pair is negative 1/2 positive √3/2, the cos and the sine. And you'll get better at this as time goes on. You might not have to draw everything. You might not have to show all that work. But in the beginning, I'm really kind of showing every step. So I know that cosecant is 1 over sine, so it's 1 over √3/2, which that's going to be the reciprocal, which is 2√3, 2 over √3, which is, when I rationalize it, 2√3/3. And that's positive. Sine is positive in this quadrant, so cosecant's also positive. It's nice when we get to like 180, kind of like the 90 degrees, right, where it's just an ordered pair, -1, 0. Sorry. The cos is -1, the sine is 0. Tan, again, will be easier, I think, to think of as sine over cos. The sine is 0, the cos is -1. 0 over a number is 0. Last one. Cotan 330, all the way to the 4th quadrant here, 330. Well, 330 is in the 30-degree family, right? 30, 60, 90 triangle again. Hypotenuse is 1. But these two values, or sorry, just the y value here is going to be negative, right? Because I'm going right and down. So my ordered pair is √3/2, comma, -1/2. This is the cos, this is the sine. So cotan is cos over sine. The cos is √3/2. The sine is -1/2, and that's going to reduce to -√3. -√3. So this opens up like a whole new ball game, right? So if we kind of think about what we did, we first learned our 16 unit circle angles in degrees and radians. Then we did our 16 unit circle angles again, the sines, the cosines. Now we're doing the 16 unit circle angles again, in addition to the sines and cosines, the tan, the cotan, the secant, the cosecant. All right, great job.